In the past, we learned how to graph complex numbers, but let's review that for just a second. If you have something in the form of a plus bi, like 3 plus 4i, you can pull out the real part and the imaginary part. So in this case, we would pull out 3, 4, and then I can graph that on the complex number plane. Now on the complex number plane, the x-axis or the horizontal axis is the real axis. The vertical axis is the imaginary axis. So that if I plot real 3, imaginary 4, literally it's the same thing as I plot a normal point at 3, 4. Now the reason we bring this back up is because we want to look at the absolute value of a complex number in relation to the polar coordinates that we have just been working with. So the definition for the absolute value of a complex number, the absolute value of a plus bi, is just going to be the square root of the real part squared plus the imaginary part squared. So again, if we go back to 3 plus 4i like we were just working with, then that would be the square root of 3 squared plus 4 squared. So the square root of 9 plus 16 is the square root of 25, or 5. So the absolute value of a complex number is also sometimes called its magnitude. We'll see that again in physics with vectors in the near future. But you also can see we've been talking about a polar point goes from the center and to a point on the circle where this is its radius. And so you can see that magnitude or that absolute value is the same as its radius value for the polar coordinate. You'll also notice that literally if we go over 3 and up 4, that's just a 3, 4, 5 triangle, right? So that makes sense to us as well as to why that distance, that magnitude would be 5. What if we had a point something like just 4i? Well, if you just have 4i, then that's 0 plus 4i. So that would be the point 0, 4. And so down here we would have the square root of 0 plus 4 squared. So we would just get the square root of 16 or just 4. So if you just have the real part of the imaginary part, then its absolute value ends up being just that. And again, that would be its magnitude as well.